Arlington snap-in connectors are not listed for armored cable without a lock nut. However, these connectors are listed for metal-clad cable, armored cable, and flexible conduit. Armored cable is a type of armored cable. It is possible that the inspector is unfamiliar with Arlington snap-in connectors and their listing for armored cable with a lock nut. Alternatively, the inspector may have seen instances where armored cable was used with snap-in connectors without lock nuts and was concerned about potential loose connections. It is recommended to attend the site meeting, meet with the inspector on site, and demonstrate how the snap-in connectors are properly installed with lock nuts for armored cable. Provide documentation by bringing copies of the connector manufacturer's listing information showing that they are approved for armored cable with lock nuts. Explain the situation clearly by explaining to the inspector that armored cable is a type of armored cable and that the connectors used are listed for armored cable with a lock nut. Be cooperative by showing the inspector the portions of the building that were worked on, and be open to answering any questions the inspector may have. By following these steps, one can help resolve the issue with the inspector and ensure that the work meets code requirements. Understanding connector ratings and cable types is crucial for electrical installations. Let's clarify some key concepts and address the concerns raised by the inspector. Firstly, it's important to differentiate between various cable types. Armored cable, often referred to as AC cable, is a type of cable with a flexible metallic covering. Metal-clad cable, or MC cable, also has a metallic sheet but differs in its construction and all-out applications. Flexible conduit provides a raceway for wires but does not inherently contain conductors. The Arlington snap-in connectors in question are designed and listed for use with specific cable types. These connectors typically feature a design that allows them to be easily snapped into electrical boxes or enclosures, simplifying the installation process. However, their suitability for different cable types depends on their listing and design. Now, let's address the inspector's concern regarding armored cable, specifically the potential issue of using these connectors without a lock nut. The lock nut plays a critical role in securing the connector to the electrical box and ensuring a reliable connection. Without a lock nut, the connector may not be properly tightened, leading to a loose connection and potential safety hazards. The inspector's point about the connectors being listed for metal-clad cable but not armored cable without a lock nut is important. Connector manufacturers specify the cable types that their connectors are approved for. This information is typically found in the connector packaging or in the manufacturer's documentation. It's crucial to adhere to these listings to ensure code compliance and safe installations. The fact that armored cable is a type of armored cable is relevant, but the inspector is likely focusing on the specific listing of the connector. Even though armored cable falls under the broader category of armored cable, the connector may not be explicitly listed for armored cable use without a lock nut. To address the situation effectively, there are several steps that can be taken. Firstly, thoroughly review the connector manufacturer's documentation. Obtain the product listing information, which should clearly state the cable types that the connector is approved for and whether a lock nut is required for armored cable installations. Secondly, prepare for the on-site meeting with the inspector. Gather all relevant documentation, including the connector listings, cable specifications, and any other information that supports the use of the connectors in this particular installation. Thirdly, during the meeting, clearly explain the situation to the inspector. Present the documentation and highlight the specific listing information for the connectors. Emphasize that armored cable is indeed a type of armored cable but that the connectors are being used in accordance with their approved listings, including the use of lock nuts. Fourthly, if possible, demonstrate the proper installation technique for the connectors. Show the inspector how the connectors are securely attached to the electrical boxes using lock nuts, ensuring a tight and reliable connection. Fifthly, address any concerns that the inspector may have. Be prepared to answer questions about the installation process, the cable types used, and the code requirements for these types of installations. By taking these steps, one can effectively address the inspector's concerns and ensure that the electrical installation meets all applicable codes and safety standards. Furthermore, it's essential to maintain open communication with the inspector throughout the process. Listen carefully to their concerns and address them with factual information and clear explanations. A cooperative and professional approach can go a long way in resolving any discrepancies and ensuring a successful outcome. In addition to the above steps, it's also helpful to understand the relevant electrical codes and standards that govern these types of installations. The National Electrical Code, or NEC, provides detailed requirements for electrical wiring and equipment. Familiarize yourself with the specific sections of the NEC that apply to cable installations, connector usage, and grounding requirements. This knowledge will not only help address the inspector's concerns but also ensure that all future installations are code compliant. In summary, the key to resolving this issue lies in understanding the connector listings, communicating effectively with the inspector, and demonstrating compliance with all applicable codes and standards. By taking a proactive and professional approach, one can ensure a safe and code-compliant electrical installation. Now let's delve deeper into the technical aspects of cable connectors and their applications. Electrical connectors are essential components in any electrical system, providing the means to join conductors and terminate cables securely. There are various types of connectors available, each designed for specific applications and cable types. Understanding the different types of connectors and their proper usage is crucial for ensuring safe and reliable electrical connections. Firstly, set screw connectors are commonly used for terminating conductors in electrical boxes and enclosures. These connectors feature a screw that tightens down onto the conductor, creating a mechanical connection. Set screw connectors are typically used with rigid conduit, intermediate metal conduit, or electrical metallic tubing. Secondly, compression connectors provide a more secure and reliable connection compared to set screw connectors. These connectors use a compression fitting to crimp the connector onto the conductor, creating a gas-tight seal. Compression connectors are often used in harsh environments or where vibration is a concern. Thirdly, insulation displacement connectors, or IDC connectors, are designed for terminating flat cables and ribbon cables. These connectors use sharp contacts to pierce the insulation of the conductors, creating an electrical connection without the need for stripping the wires. Fourthly, twist-on wire connectors, also known as wire nuts, are commonly used for splicing wires together in electrical boxes. These connectors feature a plastic cap with a threaded insert that twists onto the wires, creating a mechanical and electrical connection. Fifthly, lug connectors are used for terminating large-gauge conductors to equipment or bus bars. These connectors feature a barrel that is crimped onto the conductor and a mounting hole for attaching the connector to the equipment. Now, let's focus on the specific types of connectors used with cables. Firstly, armored cable connectors are designed for terminating armored cable to electrical boxes and enclosures. These connectors typically feature a clamping mechanism that secures the cable armor to the connector, providing strain relief and preventing damage to the conductors. Secondly, metal-clad cable connectors are similar to armored cable connectors but are designed for use with metal-clad cable. These connectors may have additional features such as an insulated throat to protect the conductors from abrasion. Thirdly, flexible metal conduit connectors are used for terminating flexible metal conduit to electrical boxes and enclosures. These connectors typically feature a compression fitting that secures the conduit to the connector, providing a liquid-tight seal. It's important to select the appropriate connector for the specific cable type and application. Using the wrong connector can result in a loose connection, which can lead to overheating, arcing, and potentially a fire hazard. Always refer to the manufacturer's documentation and the National Electrical Code for guidance on selecting and installing connectors. In addition to selecting the correct connector, it's also crucial to install it properly. Follow the manufacturer's instructions carefully and use the appropriate tools for the job. Ensure that the connector is securely tightened and that the conductors are properly terminated. A loose connection is just as dangerous as using the wrong connector. Regularly inspect electrical connections for any signs of looseness, corrosion, or damage. If any problems are found, repair or replace the connectors immediately. Electrical safety should always be a top priority. Remember, working with electricity can be dangerous. Always disconnect power before working on any electrical equipment or wiring. If one is not comfortable working with electricity, consult a qualified electrician. Now let's consider the specific requirements for grounding and bonding electrical systems. Grounding and bonding are essential safety measures that protect people and equipment from electrical shock and fire hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. These requirements vary depending on the type of system, the voltage level, and the application. It's important to follow the NEC guidelines carefully to ensure a safe and code-compliant installation. Grounding electrodes are used to connect the electrical system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The grounding electrode must be properly sized and installed to provide an effective ground path. Grounding conductors are used to connect equipment and enclosures to the grounding electrode. These conductors must be sized according to the NEC and must be securely connected to the equipment and the grounding electrode. Bonding jumpers are used to connect metal parts of an electrical system together, such as metal conduits, metal enclosures, and metal equipment. These jumpers must be sized according to the NEC and must be securely connected to the metal parts. Equipment grounding conductors, or ACs, are used to connect the metal parts of electrical equipment to the grounding system. These conductors provide a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse. The EGC must be sized according to the NEC and must be securely connected to the equipment and the grounding system. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock. GFCIs monitor the current flowing in a circuit and compare it to the current returning. If there is a difference of 5 mA or more, the GFCI trips, interrupting the circuit and preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Now let's discuss some common electrical code violations related to connectors and grounding. Firstly, using the wrong type of connector for the cable type. This can result in a loose connection, which can lead to overheating, arcing, and potentially a fire hazard. Secondly, failing to properly tighten connectors. A loose connector can create a high resistance connection, which can cause the conductor to overheat and potentially melt the insulation. Thirdly, using damaged or corroded connectors. Damaged or corroded connectors can create a poor electrical connection, which can lead to overheating and arcing. Fourthly, improper grounding of equipment. Equipment that is not properly grounded can pose a shock hazard to people who come into contact with it. Fifthly, using undersized grounding conductors. Undersized grounding conductors may not be able to carry the fault current, which can result in equipment damage or personal injury. Sixthly, failing to install GFCIs in required locations. GFCIs protect people from electrical shock and are required in many locations, such as bathrooms, kitchens, and outdoor areas. Always consult the National Electrical Code for specific requirements related to connectors, grounding, and GFCIs. Following the code guidelines will ensure a safe and code-compliant electrical installation. In addition to the technical aspects of connectors and grounding, it's also important to consider the practical aspects of electrical work. Firstly, always plan the work carefully before starting. Identify the scope of the project, gather the necessary materials and tools, and review the electrical code requirements. Secondly, work safely. Disconnect power before working on any electrical equipment or wiring. Wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, take the time to do the job right. Don't cut corners or rush through the work. A properly installed electrical system will provide years of reliable service. Fourthly, inspect the work after it is completed. Verify that all connections are tight, that all grounding conductors are properly installed, and that all GFCIs are functioning correctly. Fifthly, document the work. Keep a record of the materials used, the installation procedures followed, and any code violations that were corrected. This documentation can be helpful for future maintenance and troubleshooting. By following these practical tips, one can ensure that electrical work is performed safely and efficiently. Remember, electrical safety should always be a top priority. Now, let's consider some specific scenarios involving Arlington snap-in connectors and armored cable installations. Scenario number 1 involves installing recessed lighting fixtures in a suspended ceiling. The fixtures are connected to the branch circuit wiring using armored cable and Arlington snap-in connectors. The inspector questions the use of the connectors without lock nuts. In this scenario, the key is to demonstrate that the connectors are listed for use with armored cable when installed with lock nuts. Provide the inspector with the connector manufacturer's documentation and point out the specific listing information. Also, show the inspector how the lock nuts are properly installed to secure the connectors to the electrical boxes. Scenario number 2 involves replacing an existing electrical panel. The existing wiring is armored cable, and the new panel is equipped with knockouts for installing connectors. The inspector notices that some of the connectors are loose. In this scenario, it's important to ensure that all connectors are properly tightened and that the armored cable is securely clamped to the connectors. If any connectors are damaged or corroded, replace them with new ones. Also, verify that the grounding system is properly installed and that all equipment is grounded according to the National Electrical Code. Scenario number 3 involves adding a new circuit to an existing electrical system. The new circuit is wired using armored cable and Arlington snap-in connectors. The inspector questions the ampacity of the conductors used in the new circuit. In this scenario, it's important to verify that the conductors are sized according to the National Electrical Code and that they are suitable for the load they will be carrying. Refer to NEC Table 310.15b16 to determine the allowable ampacity of the conductors based on their size, insulation type, and ambient temperature. Also, ensure that the circuit breaker or fuse protecting the circuit is properly sized to protect the conductors from overcurrent. By addressing these specific scenarios and demonstrating compliance with the National Electrical Code, one can effectively resolve any concerns raised by the inspector and ensure a safe and code-compliant electrical installation. Remember, communication, documentation, and a thorough understanding of the electrical code are essential for success in electrical work. Now, let's delve into the importance of continuing education and staying up to date with the latest electrical code changes. The electrical industry is constantly evolving, with new technologies, new products, and new code requirements being introduced on a regular basis. To remain competent and provide safe and reliable electrical services, it's essential to engage in continuing education and stay informed about the latest changes to the National Electrical Code. There are many ways to pursue continuing education in the electrical field. Firstly, attending seminars and workshops offered by industry organizations such as the International Association of Electrical Inspectors, or IE, and the National Fire Protection Association, or NFPA. These events provide valuable opportunities to learn about new technologies, network with other professionals, and earn continuing education credits. Secondly, taking online courses offered by accredited institutions and training providers. Online courses offer flexibility and convenience, allowing one to learn at their own pace and on their own schedule. Thirdly, reading industry publications such as Electrical Contractor Magazine and EC&M Magazine. These publications provide in-depth coverage of electrical industry news, trends, and technical topics. Fourthly, participating in local chapter meetings of industry organizations. Local chapter meetings offer a forum for discussing electrical code issues, sharing best practices, and learning from experienced professionals. The National Electrical Code is updated every 3 years, with significant changes being made to the code in each edition. It's important to review the latest edition of the NEC and understand the changes that have been made. Some of the key areas that are often subject to change include grounding and bonding, overcurrent protection, wiring methods, and equipment installation. By staying up to date with the latest electrical code changes, one can ensure that their work is code compliant and that they are providing the safest possible electrical services. Continuing education is not only beneficial for one's own professional development, but also for the safety and well-being of the public. Electrical work can be dangerous, and it's essential to have the knowledge and skills necessary to perform the work safely and effectively. By investing in continuing education, one can demonstrate their commitment to safety and professionalism. In addition to formal continuing education, it's also important to stay informed about new products and technologies that are being introduced to the market. New products can offer significant advantages in terms of performance, efficiency, and ease of installation. However, it's important to understand the proper application and installation techniques for these new products before using them in the field. Manufacturers often provide training and support for their new product. Take advantage of these resources to learn how to use the products safely and effectively. In summary, continuing education and staying up to date with the latest electrical code changes are essential for success in the electrical field. By investing in one's own professional development, one can provide safe, reliable, and code-compliant electrical services.